quite often we might want to demonstrate a circuit to a class of children, and it's important that they can all see the display. So IPC Irwin make this large digital volt and ammeter with a larger display which allows a class to see it. Now it conveniently has an ammeter and a voltmeter built in together. So what we're going to do here is we've got this little motor unit with a fan on, and we're going to power it up from the bench supply there, and we're going to work out the power by measuring the voltage, the potential difference, but we're going to now introduce current, measuring a current using the ammeter here. And in later episodes, we'll look at the ammeters that we use, our class sets of ammeters that we use for practicals with the students. So first of all, I'll switch off this power supply and connect up the motor, and inside is just a simple DC motor there, and mounted on the top is a red fan. So we've now got roughly 2 volts across there, and the fan is spinning quite nicely. It's producing a nice draft above it. And so how can we work out the power? Well, we know from our formula that power in watts will be equal to the current multiplied by the potential difference or voltage. So let's take those 2 measurements using the demonstration meter. We'll switch off for a moment and then connect voltmeter in parallel with the fan. So I'm using the right-hand ports there, voltage, which has got a maximum of 20 volts. So there we are, we're in parallel with the lamp. We'll switch on, and we've got an indication there that the voltage is around 2.2 volts. So we're now going to switch off, disconnect the voltmeter, and measure the current. Now measuring current is a little more difficult than potential difference, and students sometimes get this wrong. So I'm going to show you a way of measuring current using a lead that's already attached to the measuring instrument. Now I've placed a lead in the positive port there, and this is a procedure. To measure current, we've got to make a break in the circuit and connect the ammeter across the 2 sides of the break. So if we now switch on and our motor is turning the fan there, how do we measure the current? Well, if we remove this lead there, we now actually have a break in the circuit there. They're the 2 connections to the break. And what I'm going to do is put the black lead into the negative port of the ammeter and switch it on. And now my red lead is going to go where I took the black lead from there. And the current is restored, the circuit's restored, and we've got current going into our ammeter and round back to the circuit. And it's recording quite a low current, about 0.02 amps. So if we multiply those two measurements together, we can get the power of the motor, which you can see in this graphic here. Power is current times voltage, and we can see there's an answer there in watts.